Hello learner, welcome to YourPedia Education. So we are here at IIT Mandi. Today we got an opportunity to interact with Dr. SRIKANTH. In School of Computing and Electrical Engineering, his research area is photonics. Sir, first of all, thanks for sparing few minutes for us.
My pleasure.
So before we discuss ahead related to your research area, related to the research overview under your guidance, and what are the PhD students and what are the different labs and what is your research area. So can you please give your brief introduction about your academic profile?
Yeah, sure. I am from Calcutta. I was born and brought up in Calcutta, but I'm originally from the south of India, and my whole schooling till my graduation was in Calcutta.
Right.
So I did my BSc in physics from Calcutta University. I did my B.Tech in optics and optoelectronics from Calcutta University Raja Bazar Science College.
Right.
And then I went on to do my master's with an Erasmus Mundus scholarship.
Okay.
It's called OPSI-Tech, and this was a 2-year master's.
Right.
So 1 year I spent in Warsaw University of Technology, and another year I spent in Friedrich Schiller University in Jena in Germany, and there also my specialization was optics. So my general specialization has been in optics.
Okay.
And after that, I went on to do my PhD in Aston University in UK, and this was in the area of experimental fiber lasers.
Right.
And I finished my PhD in 2015, and I continued with a postdoc at the same university. And since October 2020, I've been with IIT Mandi, and here I'm working in photonics, applied photonics.
That's quite impressive.
Yeah, it has been a long journey.
Okay, so this is your first job in India, right?
Yes, it is.
Okay, so when we talk about the photonics, as I was going to the website of IIT Mandi, I don't see any master course in photonics here, right?
Right.
So is it in PhD or what?
So at the moment, photonics is being offered as a specialty. There isn't a master's course as of yet.
Right.
And since I've just joined 3 years back, so we are trying to build some momentum. There are also government initiatives towards quantum technologies and 5G technologies.
Right.
So hopefully in a few years time, not too in the distant future, we'll surely have some photonics based postgraduate programs. We do have courses in photonics. So we have applied photonics courses, and we also have theoretical photonics courses.
Great. So I have observed one thing, that in our Indian education system, we have some stereotype of setup. Like, there are buzz around electrical, electronics, communication, instrumentation, mechanical. But students have hardly heard this name photonics. Okay, when it comes to, a decision level, that they need to decide whether to join master in photonics, whether to do PhD in these area or not. So there is one doubt aspect in their mind, that whether they will be getting some industry job after doing these courses or not.
Right.
What is your take on this?
I would surely say that photonics is actually pervading in all aspects of our life. We don't realize it as much. So the technologies, for instance, one of the biggest influences in technologies has been the LED lighting, right? LED lighting is an offshoot of solid state physics, but also the understanding of light. So if I want to give a definition of photonics, it's the generation, the physics, the generation and the utilization of light. And it encompasses a lot of different aspects. It encompasses the physics, it encompasses the engineering. And there are several applications of it. It's called an enabling technology. For instance, even CDs, they are using lasers. CD readers, CD writer, they're using lasers. Optical communications, the whole backbone is based on photonic technologies. So what I'm trying to say is, if you are actually doing a course in photonics, you are actually understanding how the current world works, right? So it is a very applied field, and you'll be understanding a lot of concepts which are highly transferable. So you can understand the fundamentals of photonics, and I often call photonics as a gateway discipline. If you are specializing in photonics, you can actually enter any discipline you want. So currently I am working with VLSI people, developing technologies for them. I am an experimentalist, I am a photonics experimentalist, I am building fiber lasers, but I am working with VLSI people. I can also work with biomedical people. So it offers you the opportunity to work in different areas. And when it comes to actually applying for jobs, people actually look for highly transferable skills. So they need to know whether you can carry over the concepts which you have learned from books or in your formal education. Can you transfer it to the real field? There can be no better field than photonics to understand how to transfer concepts from books to the real field.
See, it's truly, I agree to this point because there are so many real-time applications which are based on the photonics, and even we are using in our daily life and commercial life, day-to-day life, we are using, right?
Sure.
But even though students keep on asking me today this question, sir, we are listening a lot about artificial intelligence, sir, we are listening a lot about machine learning.
Sure.
Sir, is it right to go with photonics or we need to choose AI and ML? Actually, they are not clear that one is domain knowledge and one is the technology knowledge.
Sure, sure.
So in today's world, as per your experience, since you are into IIT Mandi last 3 years, so you are also setting up lab here, right? So IIT Mandi is working in this direction that how we can integrate these technologies into advancement in photonics. I'm talking about AI and ML.
So I can give you the general picture.
Yeah.
So the general picture is this: IIT Mandi is working extensively in the area of AI and ML, and more importantly, they are seeing approaches by which they can incorporate AI and ML techniques into their own disciplines.
Right.
Because one, of course, you can approach AI and ML as a theoretical subject in itself, and you can specialize in it and you can do research in it. Right. On the other hand, there is a big boom in using AI and ML techniques in other disciplines.
True.
And that is really helping these individual disciplines flower a lot. Right? So at IIT Mandi, people are working using AI and ML techniques in biomedicine, they're using it in sensing, they're using it in structural health monitoring. And for sure, you can use these techniques, and still, if you want to enter AI and ML and you still like your discipline very much, you are in that path that, oh, I like physics, but I want to do AI and ML because I'll get a job.
Absolutely.
I would say that stick to what you like, because that is where your intrinsic motivation lies. AI and ML, you can treat it as a tool and you can use it to advance the field itself. Right. So similarly in photonics, there is a huge boom in using AI and ML techniques, and even in India, a lot of people are working using AI and ML techniques in photonics to realize very simple devices which have profound impact. So just like using a simple multimode fiber, this is actually work happening in one of the IITs. So using a simple plastic multimode fiber, if you combine it with AI and ML techniques, you can figure out how much weight is being placed on that plastic fiber, where it is being placed. A lot of things can be done in a very simple fashion.
And they can lead to some different
And also now there is this very big Make in India movement where students are actually being motivated and they are being given training to actually realize new products. So we should capitalize on what we really like. We should not leave that. We should really protect. And on the other hand, we should also learn these new techniques and apply to our field of desire and knowledge, and then build something.
So there is one thing which I have observed about our Indian education system, that in B.Tech or bachelor education or with M.tech or MSc master education, students have opportunity that they can get exposure to internship, they can do some good project, they have some kind of coursework also. Whatever I've seen, students are not taking seriously those things. So when they want to go ahead for PhD, especially into these areas like photonics and all. So what is the prime factor as a leader, as a mentor, as a faculty you see in the academic profile of the student that it should be there, only then we can proceed ahead with the student?
Good point. I can speak for myself from the point of view of my discipline. So because photonics is this vast discipline where you can have different applications, I don't look for specific skill sets. I look, whenever a person comes to me for an interview, I ask them what they are good at, what they like, what they do, and I see where their intrinsic motivation and inherent skills lie. And based on that, I then see on what kind of project I can put them on. But one thing I surely ask them, because I'm an experimentalist, I surely ask them, have you built something at some point in your life? Because when you're building something, you are using a very different skill set. You are thinking completely differently. And I would like to see whether you have an aptitude for building things, or how much of an aptitude you have for that. Because at the end of the day, we can read a lot of concepts and we can kind of theorize a lot of things. But if you're not able to realize it in real life, or bring a product which will actually change lives, then we are not really hitting our objectives. So one thing I surely see is, are you building something with your own hands? For instance, you're talking about internships. A lot of students come to me and say that, yes sir, I've done this internship or that internship. And then I probe a bit deeper, and then I realize that some of them are very bog standard, as you would call it. It's a pre-made experiment. So what happens with that is you're already following a known path. You're not really expanding your horizon.
There is no novelty in that.
Yeah, well, I also don't expect a lot of novelty from students, but what I would like to see is whether they are able to think beyond that small framework of experiment that they are doing. And that is where we really need to push. And this is at a systemic level too. Students should be encouraged to build more.
Right. So my next question, Dr. Srikanth, is related to this only. Right, we are sitting in IIT Mandi. Obviously, students here have facilities.
Sure.
But still, there are many colleges in the vicinity of this IIT, or
Sure.
even in the state of Himachal Pradesh.
Sure.
Student might not be getting that much opportunity. How you see this? What is your view on this? That students are doing their engineering from some local colleges. So what is your message to them? What I believe today's in each IIT there are internship opportunities, there are short-term courses. You can join those campus. So what is your take on this? Are these the barrier in basically path of any good researcher that we are studying from the low college? That is this basically predefined structure that only if you are from the good college then only you can become a good researcher? What is your take on this?
It is a very loaded question. I will say that it's a very loaded question because I cannot offer a solution, and there are several hurdles. I completely agree with that. But one thing I will surely say is today the world is very open, and I mean that in two ways. One, you have the full internet that you can access. That is one. The second thing is I'm using open, the word open in a very specific way because you have access to open source materials. And I am a strong believer on open source. And I have also, for instance, I understand this particular hurdle that you don't have access to high quality equipment everywhere. And it is not, for instance, I am teaching a measurement and instrumentation course, and I understand how important it is to work with real world devices. But if you look at all these big labs, you'll have all these ready-made experiments available, and each kit costs like 50,000 or something, and for each experiment. This is not really practical. So now there are a lot of open source materials available which allows you to realize those simple experiments at much lower costs. There is the Arduino movement, there is the Raspberry Pi movement, and you can build a lot of things, and students are building that. But they need to approach those subjects in a very structured way, and that structure already exists out there on the internet. You have the MIT open course where OCW courses being offered. You have NPTEL. NPTEL is a big boon, and NPTEL is a highly structured course being taught by IIT people, IIT professors, well-established professors. I myself sometimes watch these lectures, and there are also several professors who are putting out materials for building out for free. So I have put out some coursework. I put out my whole measurement and instrumentation course, how to make the experiments for free online. So with a minimal investment, even colleges can adopt that and they can build their own setup. It is a hurdle, I agree. There needs to be some push from both the student side and also from the administration side, where they can meet together and say that this is the requirement. But it is no longer a very big hurdle. They can actually come together and they can realize this.
So as you told that you are into experimental study, right? So right now in pandemic we have seen students who are not able to do the experiment study much. They have their project or almost all things in the simulation or in theoretical based. So at that time, wasn't it quite challenging for you how to analyze and how to judge that whether actually this work is being done by student or not?
It's very interesting that you ask this question because we actually, I along with another colleague, we actually implemented online hardware labs. So what this means is the students were sitting all over India, but they were accessing real world experiments here at IIT Mandi. So we use the Raspberry Pi platform and we connected digital devices because you can control digital devices. Students were accessing the Raspberry Pi remotely and they were writing codes and they were making things move literally here. So that was one of the, you are very right that we were scratching our heads because this was the third wave. This was not yet, this was the Omicron wave when we were not really sure whether the students will come back. And we also didn't want them to lose out on the learning opportunity. So we devised this course where students were actually accessing these experiments via online and doing things with real world devices.
So it was paid or free of cost?
This was for students of IIT Mandi.
Only IIT Mandi?
Yeah, this was
not open, right?
No, it wasn't open. It wasn't open because it was a structured program.
It's still going on or now it's over?
Now we have all our students here on campus. But if it so happens that some student is unavailable on campus, we can set up this experiment for them and they can do it remotely.
Okay, so Dr. Srikanth, can you tell me about what are your current research area in photonics here in IIT Mandi?
My current research area is I'm currently building a fiber laser lab here, and it's in general it's an applied photonics lab.
Right.
But currently I have a project which requires me to build low noise mode locked fiber lasers.
Right.
So I have to experimentally realize them. So it's a 3-year project. I'm in my second year right now. It just started.
That's great.
Yeah, and I'm setting up a lab here. You know how difficult it is.
So you're
to set
taking
up.
initiative to set up the entire.
Yeah, absolutely. And the other thing is, photonics is also, since it's highly specialized, the equipment which supports the photonics research is also very expensive.
Right.
So one of the initiatives that I'm trying to develop here is build everything from scratch.
Right.
It is a bit difficult, but in the long run it will pay off high dividends, because then I'll be saving a lot of money and also I'll be training students. So
Also, it's a sense of relief also that you have contributed something good for institutions and country.
No, for sure. This has always been my focus. When I started my masters, I always wanted to come back and teach.
Right.
And I wanted to come back good research, and most importantly, I wanted to train the next generation of students so that they can go outside, get that exposure.
Right.
And I'm very happy that I'm here today and I'm able to do it.
So currently, how many students are under you for PhD?
Currently, I have 2 PhD students, and I'm looking for more. So there'll be an intake very soon, and I'm looking for more theoretical students who would be interested in working theoretical aspects and also experimental aspects.
So Dr. Shrikant, one problem with students is, especially when they want to go for PhD, I don't know why they keep on asking this question that, sir, whether we will be getting good placement after 5 years or not. I don't know what is the logic behind that, how you can anticipate what will happen after 5 years, right?
Right.
See, student in today's world, I think they have different mindset. They are looking at everything from the job point of view. Ultimately, what is the end thing we are getting? So what you would like to recommend on this?
I actually empathize with the students, and I empathize with the students because we have experienced a pandemic in our lifetimes, and that has completely changed the worldview and the perspective of the students.
Right.
This said, yes, you can actually go for a placement position after. So research opens up 2 paths in front of you.
Right.
One is where you go and you take the academic route, which is the very classical route. You do a postdoc and then you get into an assistant professorship and so on and so forth. And you also have the other possibility where you are using the skills you have learned in your PhD and going for an industry job.
Right.
Speaking in terms of photonics, the photonics industry in India is growing.
Right.
And there is a lot of active research happening. So for instance, there is a big movement towards quantum technologies, as you may be aware. And there is also a big movement towards 5G technologies. Right. So in a couple of years' time, there will be a requirement for workforce, specialized workforce, not just postgraduate engineers. I'm talking about people who have deep tech knowledge, because you have to push the envelope. You want to realize these technologies indigenously. So for sure, I can guarantee that there will be options.
Also that R&D sector is now a lot more improved as compared to it was earlier in India, right?
Right. Yeah, for sure. There are several more opportunities, and AI and ML is also, I must thank AI and ML technologies for that, because now you can use these technologies to push, again, like I said, the envelope for the existing technologies.
So next question I am asking on the behalf of all researchers who will be our viewers.
Sure.
So they find always difficulty in doing the literature review, in finding the research problem, and then to assess what is the novelty, up to what level novelty should be there. It might be different view of different person. Then what is your take on this?
Yeah, that is actually a very good question, and that is also a question I often grapple with, because as an active researcher, I'm always scoping for new areas, and it is not an easy job. It is challenging, it is time consuming, and it is also a mark of a good. This is also one of the aspects on the basis of which students are actually evaluated, whether they're able to do a good literature review, whether they're able to find the research gap. And this boils down to an actual evaluation of a PhD student. That is what makes you. This said, there are a lot of tools available these days, which makes life a bit easier. Right? There are AI and ML tools, and there are also bibliographic tools available. Not everybody is aware of it. So what I have also tried to do is I have tried to give these soft courses to students.
Related to these tools.
Related to these tools. So I talk about literature surveys. I talk about how to write, because writing is also a very important part.
Sir, can you mention our viewer what is your YouTube channel? Is it on your own YouTube?
Oh yeah, it's my own YouTube channel. channel, and my name is SRIKANTH. It is by my name, and I'm more than happy to share a link.
Right.
And I put these are slightly longish videos, but if you watch those videos, you'll be saving a lot more time than the time spent in
Oh,
watching.
definitely, sir. It will help a student if it's coming from you. So, sir will be putting his link in the description. So, if you want to see how to proceed the literature review and if you got the findings, then what should be the next step? So, you can watch that videos and it will be quite helpful for you people. So, can we move ahead, sir? Can we proceed ahead?
Of course.
Yeah. So, my next question is, you are taking here undergraduate courses also, right?
Sure.
And you are also setting one lab and you are also having some PhD researchers.
Sure.
So, which thing you find most difficult?
Oh God. Each has its own complications.
Right.
I love interacting with the students.
Okay.
And I've found that my interaction with the students are more vibrant and joyful when I'm working with them in the lab.
Right.
Because then I'm working with them closely. When I'm sitting and lecturing the students, it's not, the interaction is a bit more constrained.
Right.
And in that sense, I would say that I enjoy my time teaching. I enjoy my time actually building the labs for the students, because I see how much of knowledge and how much fun they have doing these experiments. Building a research lab, yes, it is very, it's not an easy job.
Right.
I understand how difficult it can get, given the fact that setting up an infrastructure is quite a prolonged process.
Right.
So, but I'm also enjoying it, and
There is
I'm
a
also
lot
learning
of
along
cross
the way.
functionality also involved in building a setup, I guess.
Yeah, you can say that, yes.
Okay. So, sir, my last question is, how the passionate researchers who are really passionate about photonics, they can approach you if they have some good research work in the past?
Okay, so I'm presuming that you're talking about prospective PhD
Yeah,
students.
prospective PhD.
So the best way to reach me is via email. So they can always write me an email,
Okay.
and they can send me their CV, and they can send me a brief about their project. And like I said, I also have shared a brief bio/introduction about my lab on my YouTube channel.
Okay.
I've also mentioned there that you don't have to work in my area of work.
Right.
You can come with your own ideas, and we can see how we can take it forward. So, and of course the student will be leading the research. I'll be taking a back seat, and I'll be guiding them along the way. So in that sense, I'm more of a guide rather than a supervisor.
Right.
So I would prefer to be called a guide, and I would help the student move it forward. So for sure, I'm open to emails. Emails is the best way to go.
So, are you enjoying Himachal?
Oh yeah, so much. One of the reasons why I came to Himachal, because I was doing my PhD in UK for almost 9 years, PhD and postdoc for 9 years. I was looking for a place where I can come and I can retire. So I found my place to retire.
Great. So it was a nice conversation with Dr. SRIKANTH. So it's a wrap up time. Sir, thanks for sharing, and
My
thank
pleasure.
you so much for your time. So you really shared some great valuable insights related to your research area photonics. Definitely it will be a great knowledge bank for the student or for the aspiring fellow who want to come in the photonics department. Thanks a lot, sir.
My pleasure. Thank you very much.